Hello, and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome to this episode. I hope that you're well. What are we going to talk about today? Well, we're going to be discussing what is the difference between physical, organic, and inorganic chemistry. One of those topics that comes up time and again. And we're also going to say how much it really matters, how much these labels really matter. Okay, so we often hear chemistry split up into these three topic groups. Depending on your exam board, you may find that your exams are split according to these two. So, what are they and why does it matter, or does it matter? Let's take a look at them one at a time, starting with physical chemistry. Physical chemistry includes topics such as atomic structure, bonding, amount of substance, reaction types such as equilibria and redox, and energy changes and kinetics that happen when chemical reactions occur. We usually include thermodynamics and entropy, electropotentials, and pH-related studies, so acids, bases, and even buffers. So as you can imagine from that list, there's a lot of calculations involved in physical chemistry. How about inorganic chemistry? Well, inorganic chemistry includes the periodic table and its implications. Periodicity, in other words, the changes that are seen across a period of the periodic table. We tend to focus study on group 2 and also halogens and transition metals. We choose those as study areas within inorganic chemistry. We also look at reactions of ionic compounds and metal ions, and we also look at reactions of ionic compounds and of metal ions in aqueous solution. Finally, we have organic chemistry. Organic chemistry is the study of carbon-containing compounds, their characteristics and their reactivity, with just a few exceptions. So carbon is quite unusual in how readily it forms bond to other carbon atoms within compounds. This means that carbon forms chains within molecules, and these chains can be of various lengths. They can be straight, they can be branched, they can even be ring structures. And this results in an enormous range of molecules that contain carbon, and therefore an enormous range of organic compounds. Carbon is, of course, bonded to other elements within these compounds too, and that means we get families of similar compounds. At this level, we study some of those families of compounds, discuss their structure, their properties, their reactions, how they're formed, and so on. Because there's such a range of organic compounds, chemists have developed many analytical techniques to identify and characterize organic compounds. We'll look at some of the chromatography and spectrometry used and learn how to use the analytical data to identify or distinguish compounds. Organic chemistry also introduces us to reaction mechanisms. These are the reaction pathways that occur when organic reagents react, and they show which bonds break and form during a reaction. So that's the three areas: physical, inorganic, and organic chemistry. And of course, there is overlap, very much overlap. For example, every compound is either organic or it's inorganic. So every time we need to consider the number of moles created, for example, or an energy or enthalpy change, or use any other measure that is considered physical chemistry, we must also be, to some extent, considering organic or inorganic chemistry at the same time. So that brings us to, does it really matter? Does it really matter that we have these labels of topic areas? Well, that very much depends how your brain works. If you have a brain that likes to compartmentalize lessons, questions, topics, then maybe it will matter more to you. If you feel the need to get into a particular mindset, depending on the question type or lesson topic, then it may matter to you too. But in my experience, many larger exam questions will include more than one of these areas. So it may help you to be or to try to become more of a big picture thinker anyway. There's no marks for correctly identifying which area has been considered. The marks are for understanding whatever the chemistry is there. In summary, we've talked about what is physical chemistry, what is inorganic chemistry, and what is organic chemistry. We've talked about what those topic areas are. We've talked about whether that is really useful to us. And that depends to a certain extent on how your mind works. And that's going to be different for each one of us. And we've also said perhaps it's not that important after all. There's no marks for identifying, this is physical chemistry question. This is an inorganic chemistry lesson. It might just help you organize your lecture notes. It's probably not going to help you during an exam. I hope this has been useful to you. If you have further questions about this, please include in the comments below. If you're listening on a platform that doesn't have comments, I've included my email in the episode notes, so contact me there. Thanks for listening. Don't forget to subscribe so that you don't miss out on the next one. And I look forward to speaking to you soon. Thank you for listening to this episode. I hope you found it useful. And if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode. And until then, do look after yourself and goodbye.